we've established our first two relationships. So we want to consider an ellipse on the Cartesian plane where the center is HK and a point in the circumference has coordinates XY. We want to think about the length of the sides of two right angle triangles. The first of which is this guy. So easily the hypotenuse of that triangle is D1. The length of the horizontal side is going to be the sum of C, so this piece right here, and this additional piece on the right hand side. So we could start by saying that that side is C plus, well, this remaining piece on the right side, where that piece will be the same as x minus h. So the difference in those coordinates, x subtract h, let me put that in a bracket, so x minus h. And you can see this if we just consider what that length x minus h looks like. So the length x is this distance here. The length h is going to be, well, this distance here. And the difference in those lengths clearly will give us that remaining piece of the horizontal side of that right angle triangle. And then, well, similarly, the length of the vertical side will just be y minus k. So we can see that the length of this vertical side is just y minus k for a similar reason. So we could go ahead and see that, well, clearly y will be this entire length going up here, and k will be this guy. And we could go ahead and say that the difference in those guys, y and k, is going to give us the length of that vertical side. So we can now apply Pythagoras' theorem and see that d1 squared is equal to, let's call it c plus x minus h squared. So c plus x minus h, so x minus h all squared, so that's the length of the horizontal side, plus the length of the vertical side squared, so easily y minus k squared. Let me use the same color, so y minus k squared. And we could go ahead and square both sides of that equation, or rather take the square root of both sides of that equation to transpose for d1, where d1 there will be just the root of c plus x minus h all squared plus y minus k squared. And, well, we could do the same type of thing for the right angle triangle on the right hand side. So if you consider the length of the sides of this right angle triangle here, you could apply Pythagoras' theorem. Well, we already have the length of the vertical side, which clearly is also y minus k. The length of the horizontal side will just be the difference in the whole length c and this piece on the left hand side, but we've already found the length of that piece on the left hand side, which is x minus h. So we can go ahead and see that the horizontal length of that right angle triangle in yellow is just going to be c subtract, again, this piece here, which is x minus h, so that guy minus h. And again, we do the same type of thing. We are using Pythagoras' theorem to see that c d2 squared is going to be equal to, let's see, it is c minus x minus h all squared. So c, let me again use the appropriate color. So c subtract x minus h all squared, x minus h all squared, and, well, plus the length of the horizontal side squared, so plus the length of y minus k squared, y minus k all squared. And, well, same type of thing here. We could transpose for d2 by taking the square roots of both sides to see that, let's say, d2 is equal to the root of same thing, c minus x minus h whole squared plus y minus k squared. Last thing we want to do here before we derive the equation is just make a small substitution. We're going to let x minus h be big X and y minus k be big Y. Purpose of this is just to make the derivation a little tidier. So instead of having all those extra terms hanging on, if we make the substitution and we work it all the way to the end, it means we can just put these guys back in when we're done. So we're going to go ahead and rewrite each of those equations as, say, d1 is equal to the root of, let's say, c plus, call it big X whole squared, plus, well, big Y squared, and then d2 is the root of, say, again, c minus big X whole squared plus y squared. So this is our starting point. We now have the tools that we need to derive our equation.